In our final video of the chemical reactions unit, we're going to look at how to solve the most difficult type of problem in the entire unit, that being using the reactants in order to figure out what the products of a chemical reaction are going to be. The first step is to figure out what the type of reaction is that's going to happen, because based on this, we can predict what the products are going to be. So to do this, we need to take a detailed look at our reactants here, so we see that both of these are actually compounds because, again, they contain multiple elements instead of a single element, and we can check the periodic table to see whether each of these is a metal or a non-metal, so that we can figure out whether each of these is going to be an ionic or a covalent compound. We see that aluminum is a metal which has a charge of +3. Bromine is a non-metal that has a charge of -1. We can see that we had a polyatomic ion which happens to be sulfate, which has a charge of -2. So this is going to be an anion, and potassium is a metal that has a charge of +1. So because each of these are metal and non-metal, or cation and anion combinations, we can see that each of our compounds is an ionic compound, meaning that we can designate each of these as AB is our aluminum bromide compound, and CD is our potassium sulfate compound. So from this information, because we've determined that each of our compounds is ionic, we can figure out that this is going to be a double displacement reaction, and it's not actually that difficult to figure out why. We know that this isn't going to be a decomposition reaction, because a decomposition reaction has one compound that breaks into separate elements, and it's not likely going to be a synthesis reaction either, because that would be two elements joining together to make a compound. It's not going to be a single displacement reaction, because that's an element reacting with one ionic compound, and we know it can't be a combustion reaction because there's no carbon compound and no oxygen by itself, and we know it's also not going to be a neutralization reaction because we don't have any OH-, which means we don't have any base, and we don't have any compound that begins with hydrogen, so we have no acid. What we've done here by identifying the type of reaction by looking at each of the compounds and writing out A, B, and C, D is that we're using the general form of a chemical equation in order to help us identify what the type of reaction is going to be. And in double displacement or double replacement reactions, we know that our reaction is going to have the two metals, or the two cations rather, switching places such that our products are going to become AD and CB. So we can write out tentatively what our products are going to be, where our A is aluminum and our D is sulfate. Next, we can figure out what the proper chemical formula is of aluminum and sulfate together. We remember from our periodic table, aluminum's charge is +3 and sulfate's charge is -2. We know that the common factor between +3 and -2 is 6. So 3 times 2 is 6, so that means that we need 2 aluminum atoms, or 2 aluminum ions, and that will give us +3 times 2 is +6, and -2 times 3 is -6, so that means that we need 3 sulfate polyatomic ions, and we can see +6 minus 6 is 0, so our charge is balanced. Next, if we write our CB compound, we know that C is going to be potassium and B is going to be Br, bromine, and since potassium and bromine have the same magnitude of charge, +1 and -1, our chemical formula is done. So what we've just done here is that we've determined, using the general formula or general equation for our type of reaction, is that we've used it to determine what the unknown products are and used everything that we know about writing chemical formulas in order to write the products correctly. And our final step is to actually balance the reaction here, which is relatively easy because we don't have really any oxygen or hydrogen. So let's go about it one element at a time. Our products have 2 aluminum, so let's put a balancing coefficient of 2 there. Our products have 3 sulfate, so let's keep the polyatomic ion together and just write a 3 in front of potassium sulfate. And then we can see that we have 2 times 3 is 6 bromine and 3 times 2 is 6 potassium. So we can write a coefficient of 2 here. And if we put a 1 in front of aluminum sulfate, our reaction is complete and balanced. Now, the only thing that we're technically missing is the state of matter. We don't know whether our products are going to be solid, liquid, gas, or aqueous because you don't have the tools to figure this out yet, because that's okay. Because as long as you follow these 3 basic steps, that will allow you to identify what the type of the chemical reaction is and use the general equation in order to predict what our products will be. So see if you can put this knowledge to use by identifying what the products are of each of the chemical reactions below and balance each of the reactions using the tools that you were given from the previous videos.